Well, hello everybody. Welcome to Greg's Vintage Workshop. Today we're doing part 2 for the BK Precision 2830 digital multimeter. Today we're going to be doing the calibrations on it and the final reassembly. In part 1 we took it apart, I made repairs, replaced a fuse, replaced this banana jack here, made it a fused banana jack. I did put it back in the housing and then realized I needed to have it out of the housing in order to calibrate it. So the other thing I've got is, it showed up today, is the instruction manual for it, which is actually a very nice manual. Get it done where I can show you sort of some of this. Besides having calibration procedures, I had a parts list and complete parts list, a little addendum on it, very thorough, gives you the how to operate it and such. It was a good purchase. Even had the business reply card on it for the warranty information. So anyway, that came today, so now we can go ahead and set this thing up. So I'm going to put you in a tripod from a distance so you can watch the meter. Let me show you a couple of the adjustments here, so because you won't be seeing me do them. So we have a couple of trim pot adjustments right there, and we have a couple of trim pot adjustments right there, and then on the back we have a trim pot adjustment right there. So those are the ones that we're going to be using to make the adjustments on this, and I will be reading it right out of the manual and we will do it live. I've got my little DC power source. I've got my variac and power source there, so I can control some voltage and such with it. I've got a box of resistors over here, so we will get started. Let me get you in a tripod. Okay, so I got you set up on the tripod. I've got some leads on this meter right here, alligator clip. So right now we are set up in the ohm section, and let me get the book out. We're going to see what the first thing we need to do. So it says preparation check, plug the red test lead into the ohm and amp jack, which is what we are right here, and the black test lead into a ground jack, which is where we are right here. It says set unit on, and depress high ohm function and the 10K ohm range switches. So we got the 10K ohm is this one right here, and then the high ohm function is right here. Okay. It says without resistance connected across the test leads, overrange indication should occur, which is what the flashing 1.99 is, the out of range, what you get when you're out of range or open. So if we short the test lead, it says it should produce a 0 reading. So let's go ahead and short these test leads together. And we're 0.00, so that's correct. Okay, it says depress the ACV function, AC volts, and switch to 1000 volt range. Okay, let's undo those. Let's switch to 1000 ACV and 1000 volt. Okay, so we're going to start the variac. We're in AC volts with that lead. Alright, variac's on. I'm going to take it up to 50 volts per the analog meter on the variac. That's 50-ish right there. And we're right on the money, 50. Alright, good. Take it on up to 100 per the analog meter here. Right on the line right there. 100 volts, right on the money. Take it up to 120 per the meter here. Yeah, it looks like 120. 121, okay. So since I'm on an analog meter, I guess it's entirely possible, but looks pretty darn close. Alright, so we're good there. So we shut off the variac. Let's see what's next. Alright, so now we're going to check DC voltage. So we're going to select DC voltage. Right there. And it says press appropriate range switch is required for the voltage amplitude to be measured. Alright, so we're going to be measuring off of my little power supply here, which is basically the highest voltage is about 12.5 maybe. So let's put it on the 100 volt range around DC, 100 volt, and we will connect up to my DC power supply. Flip it on, and we will go to the 12 volt side. So there's the red, and I'll just take my probe and I'll stick it into ground. And we're at 12.3, 12.4 volts. Now I'll go to my 5 volt line. And we're at 5.1, 5.0. And then I'll go to my 3.3 volt line. 3.3, 3.4. So that looks right. So next, we're having to check the AC voltage again, varying voltage, which is what I've already done, so that's fine. Alright, now we're going to go to resistance measurements. So let me get that out of that. I'll move this over to resistance. Alright, and it says connect input test leads to the ohm, which I just did, the ground jack, to press the high ohm function, which is going to be this one. To press the range switch to select the desired ohms range. I think we're going to do, let's see what I got over here. This is a 1.8K resistors here. So I think we'll go to the 1000 ohm range. And we will check 1.8K. There we go. This is a 1.8K, and we're at 1.8 with the 100 depressed, so that's right. The 100 ohm range, and the 100 ohm range, and a 10 ohm range. Let's see, 100 ohm range. Normally observe a non-zero reading a few tenths when the test leads are shorted together. Readings due to the resistance of the front panel fuse jacks and test leads. So let's see what happens when we do that. Get the resistor out of there. Let's go to the 100 ohm range. That's 1000, 100. 0 with the shorted together. Okay. 10 ohm range. To press high or low ohm. So let's see, we're in a high ohm in the 10 ohm range. There's 10 ohm. Clip the test lead ends together and adjust to 10 ohm 0 control on the rear of the unit for a display of 0.0. So let's go ahead and do that. 0.03, 02, and 3. This is the one on the back here I'm turning by hand. 02. There we go, 0.0. Alright, good. We can do out of circuit semiconductor tests. Alright, now we're going to get into the actual calibrations. To the right page. Theory of operation. Here we go, calibration. Set unit to DC volt 1 range. DC volt 1 range. So we want DC volt. And we're going to unshort these. We want DC 1 volt. So let's see, DC 1 volt. Apply a positive 1.9 volts to input and adjust R4 for reading of 1.9. So let me get back here on my DC power supply. We're going to be on the back. On my DC power supply, you won't be able to see that there's a digital up there. So let me get this stuff set up here. Get my negative on there. Let's get this thing turned. And a little bit. This is the variable one. It's 0 to 12 volt. Alright, that's about 2.4, so we will get hooked up and then we will make the adjustment as required after I take this down. Alright, so we are hooked up there, we are hooked up there, however I'm not in volts. Move it over to volts. We're on 1, but we're higher than 1, so we need to be on 10. There we go. Okay. That's obviously a misprint. It has in there apply 1.9 volts to the input, adjust for reading of 1.9. However, obviously can't do that on the 1 volt range. So you're saying adjust R4, which looking at this drawing, R4 is the bottom one on this side over here. Let me get this turned down to 1.9. Little adjustment screwdriver in there. Maybe. There we go. Right, that's 2, 1.9, 1.8, 1.8, 1.9. 1.8, 1.9, 1.9, that's 1.9. Alright, so we're 1.92, so we're pretty close. Let me get a little screwdriver. And we're doing the bottom one, I think it said. No, the top one. R4 is the top one, not the bottom one. R4 for a reading of 1.90. Let's see what we do here. Wrong way. 192, 191, 19100, 1.90. Okay. Set unit to high ohms. Go ahead and shut DC volts off. Take our leads loose. Alright. So it says set unit to high ohms, which obviously if we're going to do ohms, I got to put my lead back in there. And we're going to set it for high ohms. It's high ohms. And connect a reference resistor, preferably 1.9K, which I don't have 1.9K, I have 1.8K, that's the one I just had here. Let's see, and adjust R32 for correct reading. So R32 is the innermost one over here in the center. We're on 1.8 resistor here, so let's go ahead and hook this up. And we're at 1.80. Let's just tweak that a little bit and see if it makes a difference if we tweak it. Innermost adjustment here. If I can get on it. Yeah, okay, it moves it. 1.80. Okay, so there's that. Set range switch to 10 ohms. So 10 ohms is this one. And short the input leads and just the 10 ohm zero control for display of zero. Well, we already did that. Let's double check it. Should be fine. That was the one we did early on. Let's just see what we get. 0.01, 0.0, yeah. Yeah, it's pretty darn close. Okay. So that's done. Remove short and connect reference resistor, preferably a 19 ohm, and adjust R44 for correct reading. R44 is the bottom one on the side. It says preferably a 19 ohm. Let's see, 15 ohm resistors. And let's see what we get here. Unshort this. .79, 14.8. So the resistors aren't probably exactly dead nuts on. Let's try a different one on here. I got a whole rack of them on here. And that one's 15.05, so that's pretty darn close there. Let's try a third one. 14.93. So I'd say it's pretty darn accurate. Like I said, talks about fuse replacement, talks about the test leads, and of course there's a lot of stuff in the book telling you how to use it, but that's the calibration. So, and that's what you get when it's out of open out of range, is the flashing 19.99. So I think that's it for calibration wise. I'm pretty pleased with that. I calibrated up pretty nice, pretty accurate. So I guess that's it for the calibration. Now we just gotta finish putting it together. Alright, let's move some of this stuff out of my way. And we're going to unplug the meter. I'm going to move my DC power supply out of the way. We're going to reassemble this thing. Alright. So we're going to line our slots up. Like that. Alright. Get our screws put in. I decided I'm just going to use the cord that came with the function generator because I probably will not use the function generator very often at all. So I'll just stay with this, and then if I do want to use the function generator, I can hook it up to it at that time. So this is the leg. I'll make sure we put this on in the right direction. I think it goes like that. Springs and the retention knobs on there. There's one side. Okay, so this is the way the leg works. This is actually multi-position leg, so depending upon how you want it to be, you can fold it all the way up. It can sit flat on your bench like that, or you can flip it down to that location and you can have it so you can look straight down at it, practically straight down, or you can flip it like that and you got more of an angle on it, or you can flip it out even more like that. So it's pretty universal little assembly. I kind of like it like that, but depending upon how I put it on my bench, where I determine its final location is going to be, will determine how I actually do it. I'm thinking I might put a shelf up here and set it on the shelf, but I'll have to build that shelf. So, powered on. And we are powered on, and we are on the low. Now we're off nothing. We have nothing. And I need to put my leads on it. I gotta make me some leads. I gotta have some better leads than what I currently have. I don't have a lot of good leads. At this point in time, we got a lot of cheap leads. I don't have a lot of good leads. But that'll work for now. And as you see, when you short it, we're good. So, alright folks, that is going to do it for the BK Dynascan Corporation Precision 2830 digital multimeter. I appreciate everybody with their patience and watching this. I do have the BK Precision function generator, which is very similar. Looks like that. It's got the same leg situation on it. This seems to be complete. I'm probably going to see if I can get a manual online for it going to have to go through this as well. And that will be an upcoming series. I don't know if it'll be my next one, but it's going to be upcoming. So, another successful restoration. I'm very happy with this particular meter. I think this is going to make a very nice addition to my workshop. If you're not a subscriber and you're watching my channel for the first time, appreciate if you would hit your like button and subscribe so that you get all of the future episodes. And I've got a lot of projects that are already in there that you can see. If you are a subscriber, I thank you for being a subscriber. So from Greg at Greg's Vintage Workshop, I thank you for watching my channel. Have a great day, and we'll be back. A new project.